Hi, so today we are going to be doing lesson 6.3 where we are going to be graphing a line using its intercepts, that is, its x and its y intercepts. So we recall from yesterday that a line can be written in either one of two forms, either the slope and y-intercept form, which is y equals mx plus b, or the standard form, which is ax plus by plus c equals 0. Where a, b, and c are all integers and a is a positive integer. Now, standard form can be presented in word problems, and so in order to identify the fixed and variable costs, we first need to convert that into a slope and y-intercept form. Now, a quick note, in the quiz yesterday, a lot of people were putting the coefficient of c on the other side of the equal sign. The only time when c is on the other side of the equation and not on the same side of x and y is in the context of something called vector calculus, which we're not doing this year. So for the sake of this class, please keep everything on one side of the equation equal to 0. We start with an example, familiar example, although this one is written in standard form. The celebrations banquet hall uses the equation 45n minus 2c plus 1250 equals 0 to determine the cost for a hall rental, where c represents the cost in dollars, which depends on n, the number of people attending. We want to express this equation in slope and y-intercept form, that is, c equals mn plus b. Notice this is the same thing as saying y equals mx plus b, except in this case we redefined our variables x and y to be n and c respectively. So we begin, and we have to isolate for everything, and then we want to isolate for capital C, because that is what we would use as our y variable. So we do this by bringing 45n and 1250 on the other side of the equation and then dividing by -2, and this gives us an equation of c equals 22.5n plus 625. And so now we can use this equation to identify the fixed and variable costs. We see that the fixed cost is $625 because that's the y-intercept over here, and our variable cost is $22.50 per person, which is over here, our slope, or our constant of variation. Now we want to know what is the rental cost if 100 people attended a soccer banquet. So 100 people means that we're going to figure out the cost using this equation and by substituting n with 100, which we do here. This gives us total price of $2,875 for 100 people to attend the banquet. Now we transition into our discussion on intercepts. Now we remember that the y-intercept is the y-coordinate of the point where a line crosses the y-axis. So at this point x equals 0 over here. So this would be the point 0, y, whatever this y value is. Now the x-intercept is the x-coordinate of the point where a line crosses the x-axis over here. So at this point, y equals 0. So in this case, this would be x0. Now we want to graph using the intercepts. Now keep in mind that if you can draw a line between 2 points, then you can extend this line indefinitely. So what we do when we graph using the intercepts is that we graph the 2 points of the intercepts, and then from there we extend the line indefinitely. So for some equations it is easy to graph the line using intercepts, or easier. For example, for 3x plus 2y equals 6, we know that when x equals 0, y equals 3, because 2 times 3 equals 6. And when y equals 0, x equals 2, because 3 times 2 equals 6. And so we can tell right away that the y-intercept and the x-intercept would be the point 0, 3, and the x-intercept would be 2, 0. And so if we were to connect these two points together, that would give us a line. And so now we can just extend that line. and that will give us a line. Graphing with intercepts. We want to graph the following intercepts, 1, 2, 3, 4, and we want to graph each line that passes through these two intercepts. So we begin with the first example, example A, where the x-intercept is 4 and the y-intercept is 2. So we just draw a line that goes through these two intercepts. The second example, example B, x goes through the point -3 and y goes through -1 over here. So we just draw a line that goes through these two intercepts. Example C, there is no x-intercept and there is a y-intercept. Now keep in mind, if there's no x-intercept, then we can assume that this line is going to be parallel to the x-axis because the two lines won't meet. That's a hint for future years. You don't need to know parallel lines yet. So right off the bat, if we know that it has no x-intercept, then we can tell that this is going to be a horizontal line because it only passes through the y-axis. It'll only touch the y-axis. So that makes it a horizontal line that passes through the point -5 over here. And for our last example, example D, our x-intercept is at -4 and our y-intercept is that there is none. So what can we do with this? Well, we know then that if it doesn't touch the y-intercept, that means it's only going through the x-axis. So it's going to be a vertical line passing through the point x equals -4, which is over here. Now we can calculate these intercepts using algebra. So in order to determine the x-intercept, we substitute y equals 0 into the equation and solve for x, because the x-intercept is the point where y equals 0. And to find the y-intercept, likewise, we substitute x equals 0 into the equation and we solve for y. Because in this case, this is the situation where x equals 0. And to determine these, we don't need a graph. We just need to do these substitutions. So we start. We want to determine the x and the y intercepts of the equation 4x plus 6y equals 48. Keep in mind this is not in standard form, although this is still the equation of a line because we can bring this all the way back. So we start with the x-intercept. And we know that we need to sub in y equals 0. So we do that. We sub in y equals 0. 6 times 0, this goes away, this term goes away. So we're left with 4x equals 48, and we divide both sides by 4 to isolate x, which gives us an x value of 12. So the x-intercept would be at 12, 0. The y-intercept, likewise, we do the same thing except this time we're subbing in x equals 0. So we proceed with our calculation. 4 times 0, this term will go away and you're left with 6y equals 48. In which case now you can just divide both sides by 6 and you will be isolating for y in doing so. So then this would be the y-intercept of 0 and 8. For the linear relation 3x minus 5y plus 15 equals 0, we want to determine the x and y intercepts, and we want to graph this line. So the x-intercept would be found by substituting y equals 0 into the equation. And then we have 3x, and then this term will go away. We have 3x plus 15 equals 0. We bring 15 to the other side, and then we divide by 3. We end up with x equals -5, which is this point right here. And then we do the same thing for the y-intercept, except this time we're substituting x equals 0. And so in doing so, we substitute x equals 0. This term will go away, so we're left with -5y plus 15 equals 0, in which case we bring 15 to the other side of the equation, and then we divide both sides by -5. That gives us -15 divided by -5, which is y equals 3, which is this point right here. Now, since we have the two intercepts, we can just draw a line between them. So We do so, and this would be the equation of that line. We want to find the slope using the intercepts. So when finding the slope using the intercepts, there are two methods that can be used. We can apply the algebraic reasoning. So this was what we learned before. So we know that the x and y intercepts are just 2 points on the line. So we can take these 2 points as our x1 and y1 and our x2 and y2, and take these points and substitute their values into the slope formula to find the slope. Or we can use the geometric reasoning. Since these are, again, just 2 points on the line, we can plot these 2 points on the graph, then we can count the rise and run from one intercept to the other to determine the slope. Then, if necessary, we can reduce the fraction. So, we want to determine the slope of a line whose x-intercept is -4 and y-intercept is -6. So, we do this. X is -4 and 0, and the y-intercept is 0, -6, which we will use as our x1, y1, and x2 and y2. And then we'll calculate. Using the slope equation, we see that the slope is -3/2. Now, we want to use the geometric reasoning. As you can tell, I've already have the rise and the run. So notice how the rise is just the positive of the y-intercept. Or in this case, it's the fall because it goes down. And the run is 4. Keep in mind that the -4 is just to the left. So why are these two positive? Well, because that's a -6. That's a negative rise or a fall. But keep in mind that it's easy to calculate the rise and run of a line using its x-intercepts, because the x-intercept and the y-intercept technically give you the distance from the origin. So a y-intercept of 6 or -6 means it's a rise or a fall of 6 or -6. Likewise, an x-intercept of 4 or -4 is just a run of 4 or of -4. So, having said this, we can calculate the rise and run. We have a fall of 6 and then a run of 4. In which case this gives us -6/4, which is -3/2. So we can find the equation of the line, which is y equals -3/2 x minus 6. Keep in mind this -6 comes from our y-intercept.